Good afternoon, everyone. Thank you for coming to this session. We're very excited to be here at the Kubernetes Forum to tell you about GitOps, Kubernetes, security, and pipelines with compliance. A little bit about ourselves. I work at Rakuten as an SRE manager. My name is Ricardo, and we run a lot of Kubernetes clusters in different kinds of environments, production, staging, and QA.
And I'm Brandon, and I work at IBM Research, and I look at containers, security, and basically creating facilities to help provide security in the container platform.
Some of what we'll be talking about today, first we'll talk about why you want to have something like GitOps, then we'll talk about why security is important in the GitOps context. Then we'll talk about some tools in terms of how to put it all together with CI/CD and security. Then we'll give you a brief demo on a secure pipeline in Tecton with Minikube. Then we'll talk about what it may look like in production, having a full-blown pipeline with DevSecOps and compliance. Then we'll talk about what it may look like in the future, and finally, we'll give you some takeaways. So why do people want to have something like GitOps? So we came up with these 3 reasons, but other people may have others. But basically, people want to have a tool that allows them to compare a current state with a desired state. And not only that, but have that tool automatically change from that current state to that desired state. And then they also want to track when somebody changed something, when or what got changed, and who changed it. So for that, Git is a great tool. And they also want to be able to automate deployments to different environments, so have that transparency across a team of an organization, so everybody's on the same page. So this is kind of like what a GitOps infrastructure looks like. At the bottom on the left, you have cluster operators and developers, and then typically the developers commit code, and then that code kicks off a CI/CD process, and that actually creates a container image and gets posted to a container registry. And then you may have cluster operators managing Kubernetes manifest files and basically changing them and committing those to Git repositories. And on the right, you have your Kubernetes clusters watching all those different changes, changing a container version and automatically doing a deployment to one of these clusters like development, production, or staging. And then you have tools like kubectl or other tools that allow these folks connect to the clusters to see what's going on. So why do you care about security in all this context? So if you look at the previous diagram, you see that there's so many different endpoints when you talk about GitOps. Connecting to your Kubernetes clusters, you have your Git repository where your developers are committing code to, say, connecting through HTTP or HTTPS. And then you have also your GitOps tools, syncing container image versions to your Kubernetes clusters. So many different parts where an attacker can come in and cause some damage. And there's also vulnerabilities. So you have the package dependencies, there's container backdoors, then you have typo squatting where you may download something from a fake repository. Then there's also the Kubernetes vulnerabilities that allow you to do some sort of escalation with Kubernetes where maybe people can do things on your deployments. And then also GitOps tools specific to these tools that we'll talk about in a little bit. People also care about compliance. So there are many different compliances around the world. So a few examples are GDPR, HIPAA, PCI, FedRAMP. So many different types of compliances, and that's why they care about security. So now let's talk about some of the tools for GitOps and security. So first, we have the developer tools. We have Draft, Scaffold, and Flux. And these tools allow developers to create that workflow from the workstation to a deployment in Kubernetes. Draft and Scaffold are very similar. They have their own commands. And Flux relies on some other commands like git, kubectl, and they also have their own command to manage deployments remotely called fluxctl.
All right, so on to some security-related tools. So there's first off vulnerability scanning, which is one of the most common. So there are two types of vulnerability scanning. Really, what this is about is finding known security issues with our applications. So the first is code scanning, and what code scanning does is it looks at the libraries that are being used by your applications, as well as sometimes logic, like OWASP. And then you have image scanning, which is looking at the underlying operating system and the different packages that are being used by your application. So code scanning tools are usually language specific. So for Golang, we have GoSec. And image scanning tools, examples are Claire and Trivy. Another thing we can do in pipelines are best practices. So examples of this is for Docker files, there's Hardolint, which does best practices, including security for your Docker files. And there are also some benchmarks released by CIS, the Center for Internet Security. And they do things like, here are the best practices for Kubernetes deployments. All right, next up, we have image signing. So what does image signing actually give you? So the first thing is the integrity of the image. We want to ensure that the image, when we're running it in Kubernetes, has not been tampered with. So this is the first thing that it provides. The second thing it does is it also gives you provenance of the image. And what this means is that it can range from knowing that the image was created by a particular user all the way to something like this image has gone through a certain set of compliance checks. So depending on how you set it up, you get different amounts of provenance. So examples of this is Docker Content Trust that goes along with Notary, as well as Red Hat image signing. So we just talked about integrity. How about confidentiality? So image encryption can be used to ensure confidentiality of our images. So this is good if we work with proprietary code or secret trade secrets and secret algorithms and things like that. So what this provides is that if in the event that your registry or Docker Hub or something is compromised, the contents of your image will still not be accessible. So this is implemented in Containerd as well as Scorpio in the Red Hat stack, so you can start playing around with this. And another thing to not forget is secret management. So every time we have an application usually requires several secrets and or access to different services. So it needs credentials to access those services. So how secret management is usually done is in two parts. One is the process of creating the secret, which we define what this application needs access to, what are the secrets that we want to create for it. And the second part of this, which is as important, is defining an identity for the application. So this really means that we want to ensure that the secrets that we are creating in the pipeline are provisioned to the correct identities of applications. So we ensure that the correct secrets go to the correct workloads. So example identity in this case could be Spiffy, and then examples is Spire that does attestation of the node itself. So examples of secret management is schemas, sealed secrets, and many more.
So another interesting tool, part of the Cloud Native Foundation, is in-toto. And basically, this tool allows you to verify every single step of your pipeline. So say you have a build step, you have a test step, you have a deploy step, you have a build artifact step. All these different steps you want to verify. So it allows you to do that with basic asymmetric cryptography, meaning private and public key encryption. And it can be added to any CI/CD tool, which we'll talk about in a little bit. And then it makes it possible by creating these links between different steps, meaning if you have a deploy step and then you have, or for example, you have a QA step and then you have a deploy step, but if the QA step, somebody tampers with that, then it wouldn't actually continue. So now let's talk about packaging. So there are a couple of tools that are, some talks before this one. One of them is CNAB, and it's basically a way to distribute your applications. It has its own command line. You can add security using Notary by signing the metadata, and then you can provide that provenance, meaning know where that package comes from using a tool like in-toto. Buildpack is another tool, and it's basically converting source code directly to OCI container images, and it supports multiple languages. Can be used with this tool, open source tool from VMware called KPack. And for security, you can add encryption because it creates OCI images, so you can take advantage of that.
All right, so how do we build a pipeline? So what we've done is we have an example here, and we've broken down into four stages. So let's start on the left, which is the build. So in the build, what we're doing is we're taking the application code, and we are doing anything that's code specific. So this is where we do our linting. This is where we run static analysis, anything that's language specific. And what we get at the end of this process is a binary, right? And then we take this binary, and we want to containerize it. So in the containerization phase, we do Docker build, and at the same time, we do things like image scanning, image encryption, and also image signing. So the output of that is then this Docker image that we have that's encrypted and signed, which is great. But an application is more than just a Docker image, right? We need to define how this application will run, the deployment YAMLs. We need to define what secrets the application will need. We need to define what is the identity of the application. So this sets it in the context of how we want to deploy this application. And at the end of it, we get to the final phase, which is packaging. So this is CNAB, Helm, build packs that we just talked about. So something to note about this is that the first is that ordering in this DevOps pipeline actually matters. So an example of this is Golang. So in Golang, if you build a binary, what happens is if it's built statically, a lot of the metadata about the libraries get stripped away. So if you're running scanning, if you don't run scanning before your build step, you're actually missing out on certain metadata that you may not find vulnerabilities in. Another example of this is encryption, right? If you're encrypting something before scanning it, the scanner will not be able to work on the encrypted data. Another thing to note here is that security is not something that you can add on after the fact. So over here, we've highlighted all the security and compliance-related tools in red, and you can see that it's basically littered throughout the entire pipeline. So this is something that is integral to the entire process and has to be there from the start. So this is some of these control mappings on some of the technologies we just talked about. So this can be helpful in getting compliance because a lot of these compliance standards are based on these controls.
Now let's talk about the CI/CD tools that you can use to put it all together. So first, we have Tecton. So what is Tecton? Tecton is basically native Kubernetes pipelines. And it's basically have Kubernetes CRDs, and they have multiple CRDs. And so you have pipelines, you have tasks, you have resources. And resources are specific to CI/CD workloads. So you can create images in the resources or Git repositories. And then you can have multiple pipelines. In these pipelines, you can have multiple tasks. And the way it works is similar to Kubernetes jobs in a way that when you start a job, it goes into running state. And once it's done, it goes into a completed state. And then if your pipeline fails, then it goes into an error state. And if you want to add that extra security, you can use existing Kubernetes mechanisms like pod security policies, network policies, which is a Kubernetes firewall. And to pull your repository securely, you can use that Git SSL support. So Jenkins X is another complex tool. So it's based on the original Jenkins, but it has a lot of other components. For example, it has a chart repository. It has a way to discover those Helm charts. It uses some of the other tools that I talked about earlier, like Scaffold and Draft. It uses Draft to manage the source code, and it uses Scaffold to build and push the container images. And if you want to add that extra security, you can use auto upgrades with GitOps and Tecton. And Jenkins has its own built-in security tool with a lot of plugins, so you can use that as well. For example, integration with LDAP and different types of authorization and managing the users, for example. Another tool is Spinnaker. It's very similar to Jenkins X. I'm not going to talk about all the details, but basically, it also allows you to create that full workflow of your pipelines and interact with cloud providers and define all the steps. Demo time.
All right, so what we're going to do now is we're going to take a look at how to do pipelines with Tecton. So what we're going to look at today is we are going to start with this really, really simple Flask Python application. And we're going to show you an example of Tecton on Minikube. So over here, I can see, let me make it a little bit bigger. So I have a Minikube cluster here, and we're going to see that we have Tecton running. So the first thing we're going to look at is really what is the inputs and the outputs of my pipeline, right? So this in Tecton is defined by resources. So for this very simple example, the input of this pipeline is the Git repo that I want to build. Right. So over here you can see this is very simple pointing to the GitHub URL. And the output for this pipeline is going to be an image built, and we want this image to be in a local registry we have in the cluster. So in this case, we're going to create an encrypted image, so the tag is going to be encrypted. And finally, we take a look at the actual pipeline itself. And so for this demo, we've put everything within a single task in Tecton. So we can see over here, what we do is after cloning the repository, the first step we run here is Python libsafety, which is a code scanner for Python. And then we do a Dockerfile linter using hardolint. We use Canonical to build the image. And we go ahead and we use Aquasec Trivy to do an image scan. And after that, we do an encrypt step. And finally, a push step. So I've created all these YAMLs already. And I'm going to do a task, create a task run object, which will kick off the pipeline. So I can watch this task description over here, and we can see it's pending, which will change to running in a couple of seconds. In a couple of seconds? No? I think the internet's a bit slow. Oh, there we go. So the next thing we can do is we can look at the logs of the pipeline here. So let me scroll up here, make it a bit smaller. So the first thing that the pipeline did, we can see in the log here, is it did a git source Python app. So this is actually just cloning the Git repository. And then I ran Python safety. Unfortunately, no vulnerabilities found. And then we hit the Dockerfile lint. The build stage, which is majority of this pipeline. You can see it's really just a basic Python application over here. And then we're coupling to Docker archive, so it can be scanned by Trivy. And we run Trivy over here. It's using Alpine, which has no issues with the latest. And then we do the encrypt step, and finally, we push the image. All right, so now that this has successfully run, what we're going to do now is we're going to try and download this image to take a look to make sure it's there. So I'm going to just copy the output image here. I have this pod that should have the tools to download it. So I'm going to use Scorpio, which is a tool to manipulate images. So I'm going to say copy. Yeah, that's fair. So I'm going to get it from the repository, and I'm going to say my image over here. So it looks like it's successfully pushed. We are downloading it, and now we encrypted the image, so let's make sure that it's actually encrypted. So the first thing that we can do is look for the layer descriptor plus encrypted in my image. And we can see that encrypted is actually part of the image, the layer media type here. But let's be extra sure just to make sure that it doesn't just say it's encrypted, and it actually is. So we can go into the image itself. We can go into the blobs. And one of these big ones is a data blob. So let's take the biggest one. And what we're going to do is run, we want to see how random it is, right? So if something's encrypted, it should be pretty random. So we're going to use this tool called ENT, which is entropy. So this really detects the entropy of the data. And we can see over here that it says that if we were to do optimum compression of this, it will be compressed by 0%. That means it would be pretty random. So that was the demo for the pipeline. All these, the application itself, as well as the pipeline, is available on GitHub. So if you want to download, play with it, there's instructions on how to set it up on the Minikube cluster.
OK, so what does it look like or may look like in production? So this is out of the Jenkins X documentation. And you see here on the left, you have a developer committing something to a repository and creating a pull request. And that pull request starting a series of steps, including build, test, package, and deploy to a preview environment. And in that preview environment, you can see a basic functionality of that software. And you can have other people in the team review it. And if that's successful, basically the PR is merged. And another set of processes, just like the first one, gets created. And once that's complete, it gets deployed to a staging environment. And then you have other people in your org doing other types of tests, QA tests. You could have also maybe Selenium tests. And once that's complete, you can say automatically or have somebody push that button and deploy to a production environment. And that could be something like a canary deployment if you want to. So having the full pipeline with compliance would look something like this. So as you can see, on the first step, you will have something like in-toto to verify every single one of these steps. You will have something like Trivy to scan your container images. You will have something like the open policy agent before you deploy to your Kubernetes clusters to make sure you're not running as a root user or you're running with the right permissions. You could have something like Spire verify your workloads in Kubernetes and your infrastructure. And then on this other step, you could also have the same process in toto with Trivy. And then when you push your image to your container registry, you could have something like Harbor, another Cloud Native Foundation project. And then to add that extra security, you can have also container image scanning there. So you have that security end-to-end all across throughout your pipelines. So what does it look like in terms of the future for some of these configurations and pipelines? So maybe we'll see some new configuration languages. So the word is that YAML is great for smaller type of files, but then if you have these huge YAML files, it becomes really cumbersome to manage, and then becomes really repetitive. So some new languages are starting to show up in open source. A couple of these are QLang and DAL, and these languages allow you to embed some code in the configuration to automate some of those repetitive tasks. And then at the last KubeCon, it was announced that the pod security policies will be replaced eventually by the open policy agent. And there's an implementation for that in Kubernetes, and that's called Gatekeeper. It's an open source project, and it'll help you keep some of those configurations more uniform in your cluster, and if you have multiple clusters across your clusters. And then maybe we'll see more GitOps for cluster management. So one of the problems when you upgrade Kubernetes or the Kubernetes control plane is that your APIs constantly keep changing. So if you do an in-place upgrade, you run into the risk of your workloads not starting the next time because your definitions are not compatible. So a better approach is maybe to have blue and green deployments or Kubernetes clusters. And then you can use something like GitOps for that. And then we'll see more integrations with all these different tools. So finally, what can you get out of all of this? So think about security first. A lot of people build these pipelines, and they become just really big set of pipelines and software. And then by the time you want to come back in at that security, you have to gut it all out and start from the beginning. So if you think about security from the beginning, then you don't have to, you're not doubling your work. In patch, constantly all your components run C, you get GitOps tools, all the different protocols, so whatever you're using in your GitOps infrastructure. And then if you want to add that extra security, you care about compliance, think about encrypting your container images. You may have valuable data there. Use privileged mode to unprivileged mode to build your container images, meaning don't allow access to your /proc directory. Use rootless if you can with BuildKit and build that. There's a couple of tools that support that. And to put it all together, you can use some of these tools like Jenkins X, Spinnaker, and Tecton that I talked about. So yeah, that's all we have now. Here are some resources. Thank you very much. And then we'll be around if you have any questions. So feel free to come and talk to us for anything.